Hello, my name is Jeremiah Odero, and I'll be taking you through this SACCO and loan status checkup. By first, we are going to use NumPy to import data. We are going to use pandas. We are going to use matplotlib for plotting our graphs, and we are going to import Seaborn. From ours, we are going to train the machine. So we are going to, from this, we are going to use Scala, which we are going to read for us the data set that initially we used. So we are going to after that, we are going to use the accuracy score and confusion matrix classification report to record and score curve. So after that, we are going to load our data set. We are going to use def pandas to read the datas, and our datas is which is going to read our datas in the location which the data set is. So we are using head. So this is our recorded data that have been loaded from our data set. We are going to use the exemplary data analysis EDE. So we are going to print diff loan status to check our loan status data def. We are going to plot dot title loan status plot show. We are going to plot our data. So we are going to plot our loan status distribution. So we are going to use loan. We'll put it in form of zeros and ones. So our loan status, name count, data type, integers 64. After that, this is the plot of our diagram. So we are going to use a categorical. We are going to take our dataset categorical: employment type, loan purpose, credit history, guarantors, numerical age, monthly income, loan status, repayment default, membership year, and loan status. So we are going to convert the categorical data guarantor column to numerical. So we are going to use def guarantor, get dummies def guarantors. We are going to drop the first true data type integers. So we have data types. So this is our what we have dropped down. Okay, so def, we are going to employment type. So we are going to pick so we are going to use array self-employment informal. So from this we are going to categorically analyze this employment type. So these employment types, we are going to use this self-employment, formal. So loan purpose, we are going to know what is the purpose of the loan, if he want to use it in farming, housing, business expansion, school fees. Okay, array. So after that, so we are going to check his loan status, if it is good or bad. So good or bad, we are going to categorically place it. So this thing will convert in form of zeros and ones by data filling. So we are going to fill the places that have we are going to put these things in forms of zeros, data fillings. So these null areas, we are going to fill them with zeros, zeros, zeros. So we are going to use cool scale. We are going to scale age, monthly income, loan amount, repay default, membership here. Cool code, we are going to use employment types, loan purpose, and credit history. So we are going to scale using a standardizer scale, which will be def column to scale, scale fit transform, and we are going to process the column transformer. The transformer with standardized cool scale first. So we are going to use this to scale to the nearest. So we are going to use cut one hot encoder. We are going to drop the first. So zeros, we are going to replace it by negative 0.730221. So we are going we want to plot our, we are going to drop our data in forms of x and y axis. So we use drop column loan status, def loan status. So we are going to train, test, split, divide data set into training and testing set. So we'll be using x train, x test, y train, y test is equal to train, test, split, x and y test size. So we are going to use 0.2. The random state is equal to 42 and satisfy is equal to x. So we are going to use logical regression model training. The model logistic regression max inter 100 random state 42. So here we'll be using pipeline pre-processing plus logical regression. The model is pipeline step. We are going to use preprocessor classifier, and logistic regression. So we are going to use max inter, which is equals to 1000, and the random states, which is equal to 42. The model's fits will train the y and will train the x. So we are going to load our data from C, Anaconda sites, lab packages, scale validation data. So data conversion, so a column vector y was passed when id array was expected. So this is the diagram that already we have used our logistic regression from standard scalar plus using numerics and cards Anaconda. Categorical, we have used one hot Anaconda. Logistic regression, so we are using model evaluation. So we are going to y pred models to predict y x test. So we are using the y probability model to predict the probability x test, which is equals to 1. So after printing, we are going to look for the accuracy score of y test and y prediction. We are going to print n classification report to classify the report of x test and y prediction. So after we have done this thing, this will be our results, which will be accuracy is equal to 0.5, classification report precision. So the classification reports will produce precision, recall, F-score support. So the accuracy is equal to that. So CM, configuration matrix, which we will classify under y test and y prediction. We are going to use Seaborn to amount true, false, camp blue, treat, and that. So this will be our prediction confusion matrix, which is equal to this one and this one. So we have used to predict. So the scores will be 0.53. So this be our curve. Hope